a lot of the houses, like the back porch will be added on to or whatever. Typically the supplies aren't running there correctly to actually add. So in order for insulation to work, you have to have the proper supply
Okay.
to the insulation, because virtually what happens is the insulation warms up. That actually combats the cold. That's why the thicker, more insulation you have, the more it's going to combat the cold. But typically for additions, I mean, you'll see cathedral ceilings, which is always going to be under the recommended R value because you have less space to work with. So
Right.
if you have like a 2x6, the most you're going to get in there, normally it's R19 bat, which is typically poorly installed, so you only get the equivalent of an R9, or
Right.
R6. Also with additions, people go crazy with windows. So when you have larger wall assemblies that are mostly windows, you're going to get less R value on a piece of glass than you will in like an insulated wall. So I would first get the supply right, so
Okay.
to make sure you get enough heat, and then you can look at insulation. But I mean, typically, bungalows are 40% leakier than a typical leaky house. So we do air infiltration testing in the beginning, which is a blower door test that measures how well the house holds heat. So like that, the higher that number is, we measure with the blower door test, which has a manometer, which is measuring airflow through a fan, basically.
Okay.
So a typical house in the Midwest is 3,700 CFM 50. So the higher the leakier. I mean, I've seen bungalows at 12,000 CFM, which virtually means, the heat that you're putting in is literally going right out. So for a typical house, you want 30 to 40% of the house to ventilate per hour, otherwise whatever you cooked, you'll smell a week later.
Right.
So you want that turnover, but bungalows are excessive. You'll actually have like, an ACH, which is an air change per hour of 100%. That's why furnaces and boilers are continually running in bungalows, So all those different issues we can measure and determine with an air infiltration test, see where yours measures compared to the norm, and then you can use infrared scans to find out, in areas behind walls that you don't necessarily have access because construction materials get in the way.
Right.
We can kind of see without, it's a little less invasive as far as seeing what's behind the walls. So, but additions are tough, especially with cathedral ceilings. So after you foam and you spend a ton of money to do it and you're not getting, I'd just say kind of oversupply it. I mean, it's not the most green way, but if you're freezing in there, I mean, you can spend a lot of money and not get the results you're looking for.
Right.
So the current code in like an unfinished attic would be an R49, which would be typically about 14 inches of blown cellulose. Fiberglass is pretty close to that, so it'd be 14 inches of insulation. I mean, typically when I go in a bungalow, you'll see, 2 inches of insulation. So the more insulation, it's like a down jacket. You get the more down, the more it's going to keep heat in your, towards your body. So it's just measured per inch, and then there's certain codes for different parts of the house that need to hit that recommended R value.
I had a friend that said that I needed to knock some holes and make some more cold air returns. How important is that in the heating of the house?
Today's code now requires that for every air supply that you have to have an equal return, and that way it's supplying air and pulling it back to the furnace, so you're getting a continuous supply of warm air.
Yeah.
You'll find that homes where we've just totally started fresh with new ductwork, their energy bills go down significantly. And what we do is, most of the older homes, the supplies are in the center of the house. We actually move them to the outside so that you have a supply like under a window, and that way you're putting the hot air where the cold is, and you'll find it's far more comfortable. So I think your friend is giving you some good direction, and you will find a good improvement in the comfort if you better distribute the airflow.
I mean, our heating bill is kind of high because of it.
But it's true. Historically, you'll find that there's almost nothing in those walls. So right now, most of the bungalows, the reality is that you're able to preserve even the heat that you have now because you have masonry, because the plaster and lath, it's not drywall. As you start renovating and start doing things, if all of a sudden the plaster and lath comes out and you put drywall in, you'll notice a very big temperature difference because the masonry and the lath in that wall is thicker. It keeps the heat much longer. So it's very inefficient. the way they used to build it, which is why, you know, we have codes that always improve on what was there and can improve on their existing codes. But that's not uncommon. That's not true just for bungalows. You know, any of the older buildings, we find it in wood frame construction, which is even worse because there is no mass to keep warmth in. But it's not uncommon. You know, the code now allows you in renovation work, as you're doing improvements to spaces, definitely, you know, you need to insulate it. The code allows you to basically to insulate to as much as you can in existing buildings. But whenever you can, what we tend to do is design spaces where we'll add another, you know, 4 or 5 inches of wood framing on the inside of that bathroom on that exterior wall. So instead of taking it down and you have the wood lath against the brick, we'll actually frame in another 2x4 wall or 2x6 wall, or however much we can, to put in as much insulation as we can in that space. Although you're going to lose that heat in some of the other rooms, because if that's the case for the bathroom, that's probably the case for most of your building. And I'm sure some of the gentlemen here would love to talk about some of the options of what your alternatives of what you can do to provide minimum insulation on those walls. But you want to be able to address those and put as much insulation as you can, and wherever you can, frame in another wall, add the current amount of insulation you would need, that being walls, ceilings, whatever that is, to bring even that room up to code. And you'll notice that as you do a room, 2 rooms, 3 rooms, or even just those rooms, you'll notice a big difference, and that'll allow the other spaces to sort of start to feel a little better, and allow your mechanical systems, either the heating or everything else, work a little less hard because of you're preserving a little bit more. But it's not uncommon of the situation, unfortunately.
So you're kind of stuck with, you know, people put foam. I would tell you not to do that because it's very labor intensive and expensive, and there's not a huge benefit from a payback standpoint, because you're not going to warm up the walls because you're only working with like a 3/4 inch gap. So how much insulation can you get in there? You're still not going to be under code, and you're going to spend a lot of money to try to do that.
The fact that there's a gap between the masonry, and Simon can talk to this much better than I can, masonry has a 3-dimensional drying effect. So the fact that there's an airspace behind the plaster allows there not to have any mold forming, because moisture kind of builds up behind drywall and insulation. But that space right there, when we do a remodel, we always make sure that there's an airspace and then our insulation. So the fact that you've got, you know, no insulation, the masonry is healthy. It's not going to effloresce to the outside because it's drying in a 3-dimensional way. That's really important.
You have like 2 wides of brick with a little gap in between those 2 wides. So that's what we're talking about when we mention the gap, so you guys know. It'll be referred to often. So, yes?
Hi, I have an unfinished attic, and I understand about getting the air seal test, and I have to store things up there. So is the foam core, I guess it's called, is that the only option I have for insulating up there, or?
No, I mean, I would tell you, you're talking about going to the rafters of the unfinished attic instead of the floor. I mean,
Because the stuff in the floor is the old cellulose, but the boards are all breaking up, and you know, it's.
I mean, the problem with that is you're incorporating all that extra square footage of the attic as part of the house. So when we look to insulate and air seal bungalows, we want to basically take out the attic from the house to take out all that extra square footage. I would tell you your best bet would actually, what we typically do through the program, and then for people that want to maintain some type of storage, is we'll kind of, it's called like a dense pack underneath the floorboard. So we'll kind of pack it with insulation, which will give us about 5.5 inches of insulation. And then depending on the program and budget, you could do one of 2 things. You could leave the floorboards open and then insulate where the roof kind of pitches down where you don't have access anyways.
Mm-hmm.
So if you can get 50% of the attic to an R49, which would be along the sides, and then leave maybe 12 feet in the middle from window to window with open floorboards, I think that's a better bet, is better alternative than going to the rafters. Because you're not going to, all you're going to do is, one, you're not going to get to the recommended R value on the rafters, and all you're going to do is slowly trap heat that you're losing from your living space. And that's the big complaint, is that people aren't comfortable in their house. All we'll do is, like, all your floor joists run perpendicular to your floorboards.
Right.
So all we have to really do is pull one floorboard, and then we run a hose and it'll pack it from each side.
Okay.
So that'll get you, you get, let's say 3.5 R value, let's say you get 5 inches, so you get roughly an R20, underneath the floor, but it's packed, so it has like a air sealing compound to it too. And then on the sides, you get to the R49. I mean, in some cases, I'll put like a foam board over the flooring where people use for storage. But I think as long as we get about 50% of the to R49 and pack it under the floors, you'll see a benefit. Most of the houses that, from weatherization programs from a while back only filled under the floors, and I'll see a big difference in the heating bills of people that actually have just at least something underneath the floors. So that's kind of the way I would tell you. Don't stay away from the rafters. It won't see a difference.
Your thermal boundary is just the area that's being heated and cooled in your home. So if you're not using a finished attic, your thermal boundary will cut off at the attic floor. But if you're not using your attic space as a living space, but if you are, then it's going to come up around into your rafters. But the thing to keep in mind is you never want to have your floor and your rafters insulated. It's extremely dangerous because you have a lot of things venting up there, and it's going to trap those gases in. So just be mindful of that. If you do change and you decide to finish it, but you already had your floorboards insulated, that you have to be careful about that. So something else to keep in mind. All right, so how about you?
I can point you in the direction of a few. It's actually not very good odds in Chicago. There's a lot of masons, but there's no real restoration program in America. And I think there's one down in South Carolina, a proper restoration program. So anyone who does restoration masonry has learned it from someone else on the job, which is that's not a bad thing, but it's nice to go to school and learn. The unions have just started a new program, a proper restoration program, a brand new thing this year, I think. So that's, in the future, we'd be able to get union contractors who are really well trained.
You pay $80 an hour for it. That's
Yeah. Yeah. But small guys, what I found with a couple of contractors, the European contractors, if you mention there's a code word that I have to use. Now it's gone off the top of my head, but you have to let them know it's to the standard of a historic European building, because most people in the States want their job done to the lowest bid, and that's, they can't get that mentality out of their head. So if you say, no, I want this historically accurate, using historically accurate materials, but still finding one, I mean, I haven't really got a go-to source apart from the guys I know who have very good reputations. You can try Better Business Bureau and that, but still chancy because you can pay to be in that almost. So.
The chimney. And so
But it would have come up through the middle of the house, and that would have meant...
A lot of chimneys were located in the middle of the house.
But there was no renovation on the first floor that would have taken it out. The original floor plan shows it's right above the original bathroom.
And you may find, if you were to draw up the floor plan, a lot of times we find that there is a chimney that goes through that space, and it's located in a closet. So until you actually see the floor plan, sometimes it's not very obvious
Okay.
where it penetrates through the
Okay.
first floor. In a lot of cases, when we're doing renovation work and we're putting in new efficient equipment, we actually take out the chimney down to the level of the first floor and
Right.
leave it in the basement.
Okay.
So that may have been what happened.
And if there's efflorescence, is that something to be worried about? Because it
At this
can't
point,
be...
if it's no longer connected through the roof, then no.
Oh, okay. But if it's, like, I had cleaned it off, continued, and then
And
a
if
season
it came
later,
back?
it came back. Like,
So it could
I
be
swept it
seeping
all
up
up, I
through.
pulled it all, and then it's come a lot.
Well, there's probably still water coming in it from somewhere. Maybe you got a dripping pipe.
Okay.
It's only efflorescence is caused by water coming through.
Right,
So,
right.
Yeah.
When you go up into the attic, is
There's an addition.
Oh, okay, so
There's
they
an
probably
addition.
removed
And
this
the
part.
only... I can't even see a place between the two walls there, and there's a closet that's this big, but there's a master switch on it, which apparently used to be for the boiler.
There's a whole system of infrastructure that runs through the city of Chicago, and if you're penetrating down deep enough, they want to make sure that you're not puncturing into any of that system. The cost, that's surprising. I haven't heard that cost, but I haven't had to go through that process in a long time. So clearly I don't want to advise you to go do something without a permit, but it sounds like it's something that if you really are, your foundation really is sinking, it does need to be addressed. One thing that I have done recently for a client was just to verify that it truly was still moving. And you can buy online these little crack monitors. And what you'll do is you'll put on an epoxy on both sides of that crack monitor, glue it to the crack, and then you can take photos of it periodically and watch if it's moving.
Okay.
If it moves and comes back, then it's just the thermal cycles of the seasons, and it's just expanding with the cold and going back with the heat. If it's moving and continues to move, then your foundation really is moving.
Okay. Should I try to patch the cracks in the meantime, or just like don't touch
Check
them,
it,
or-
monitor it for a year, and over that year cycle, you'll see that the heat thermal movement. And if it comes back, then go ahead and patch it, and you can use any of the crack fillers will fill that up.
That's it, yeah, that's a basic question that you have to ask or find out whether it's steam or hot water.
Okay.
Because steam generally, when it works well, it's an excellent system. But most of the systems were tapered with and they don't work very well. You know, people remove radiators, remove vents, switch piping around, and things don't work. They bang and things happen to it. If it's hot water, then you hit a jackpot, because that's the best system there is. Okay, and you have hot water radiators. You know, there is nothing that will happen to it. It's a highly efficient system. At some point, if you want to change the boiler, you can change it for high efficiency. But the first step of making it efficient, or your house efficient, I would go here and ask for better insulation. That will be always the best first step. Don't go into high efficiency boilers and so forth. Your cast iron boiler, if it's dirt, it's pretty good. You know, you should maintain it. Find out whether it's steam or hot water, because that's a very important. Steam generally requires a little bit more maintenance, especially on the side of controls. Do you have something that looks like a blow-down valve that should be a tag that you need to open it and let the water out every week?
I haven't really looked.
Okay.
Yeah, just.
That's like giveaway. You know, this is steam system. If you have to blow down, there is a safety there, and you have to clear this little ball, that little floater, it's in there, you know, to allow it to work properly. It's a basic safety of steam system. If you have that, you have a steam system. But either one, it's excellent. A ductless split system that you can cool individual rooms or, you know, all entire house. It just depends, you know, how much money you want to spend and how far you want to go.
Cool.
Yes.
All right. Thank you.
I just want to go to one really important point,
Yes.
actually, that was just made about, especially if you're going to switch your system or get something that's high efficiency, if you're going to mess with your mechanical systems that way, definitely make sure you air seal and insulate your house first, because you're going to size that machine based on, the airflow of your house. So if it's sealed up, you can get a much smaller system. It'll be way more efficient. It won't be a weaker system. It'll be a more appropriate system.
Right.
Because if you oversize things, they actually overcycle, and it's not going to help you at all. In fact, it'll cause more problems. So just something to keep in mind. That was a good
Just to
point.
give you an idea, uninsulated wall loses about 24 BTUs per hour per square foot. Insulated wall, only 6. So 4 times as many BTUs you're losing if you don't have insulation. And it's R13 insulation only.
Insulation.
Right.
Paper insulation.
Right, so you'll have to buy a bigger boiler if you're not insulated well, you know, and everything is more expensive at that point. And you pay more also for, you know, to heat your house.
With the drywall, it would probably be easier to go ahead and take it out and fill it in the back, do some drywall, and then place it back. When you remove it, you have to be very careful. You have to do like certain spaces at a time as you're pulling it, because the nails on that baseboard are probably about this long, and you might crack it. So you just gotta make sure you're using 2 or 3 different tools at the same time to pull it very carefully, and then you can nail it back in. Are you gonna strip it afterwards? Mm-hmm. Yeah, then you want to strip it, finish it, and then reinstall it. Yeah.
And I guess if I may elaborate a little bit, because it's not uncommon, you'll see what they did, just so you understand why it's sunk and what they brought up, is that the old plaster in time will crack, and a lot of it had the old lead paint on it, and there's a lot of issues with plaster, and if they don't maintain it, it'll continue to crack, and eventually it flakes. And so some people, they find it easier, instead of repairing it, once it's gone beyond the point of maintenance, that they'll put a good 1/4-inch sheet of drywall on top of it. Because for someone else, sometimes it's just easier for them to make that look go away by putting something on top. So when you talk about taking it off, there's you're going to have a gap that's behind there. So there's a little bit of a task ahead of you of being able to fill that in. Sometimes you'll have to cut some wood. I mean, you can take your time and do it, but you're going to have to bring it back up to the same front height. And because that wood has been in there for a very long time, it's much drier. So it's not as flexible as new trim would be. So you're going to find that in a lot of those places, it is going to break. You won't be able to salvage all of it because it is so dry. And it's probably so well nailed in that in a lot of portions. So you take your time and be very careful with it, and you can hopefully salvage most of it. And there are companies and places where they do make original replicas of woodwork. They're harder to find to match your existing style, but they are available, and you may want to at least know what your options are for when pieces do break, because they will. At least you know where you can get replacement pieces to match the original.
How often do you clean your gutters?
Well, I clean my gutters probably on an average of maybe once every maybe 15 months, something like that.
You might need to do it more. Often we find that that's probably the primary cause of a leaking basement, is not cleaning the gutters enough.
Okay.
Probably twice a year is a better option.
Okay. Less expensive too.
Yeah, yeah. If you're not getting up on that ladder yourself, that can add up. But,
Yeah, that's true.
Can you explain
and
why
then
that
making
would
sure
be
that the ground around your house pitches away, which often means that you're pitching to your neighbor's house. It's kind of a little fight there.
Yeah.
But if you can, sometimes putting in a permeable paver, like a brick paver instead of a concrete, will allow it to penetrate the earth rather than spilling into your basement.
Yeah. Okay. It's the same area, the same area,
spot.
Same spot.
And so look if it's close to a gutter, downspout.
Yeah.
And see how closely correlated they are.
The neighbors is pitching it towards your house, so if the ground goes that way. So the cheapest route, honestly, is get 6-inch gutters, which is the recommendation for the rainfall intensity. So in your heavy rains, you need a 6-inch gutter and get the 3x4 downspouts and put them in every corner with a positive pitch. So it should pitch a 1/4 inch per foot to the downspout. So what happens is, and kind of steamroll off that, is that the water's overflowing your gutter in that spot, or the drainage of the water is going right to that area, probably, in most cases. So, people are buying permaseal for 15 grand. You could spend $2,000 and get new gutters, and I fix 9 out of 10 issues that way, in the city.
Mostly where you have a lot of bungalows, usually there's a lot of tree canopy. So no matter what you do, maintenance, is basically the big key to that.
You have efflorescence where there's a leak, so that's a warning sign. If you're walking around your house and you see efflorescence on your masonry, there's going to be a leak. Either the gutters are overflowing, blocked up, like I said before.
Do you guys know what efflorescence is, though, in the first place?
No.
So they're like the white salts that you'll see on brick, which you see
Yeah.
kind of everywhere.
It's
It's pretty common.
as the water's coming through the brickwork and drying out, it deposits crystals, salt crystals, and that's what it is. So it's usually a warning sign that something's leaking. It might be the tuck pointing. It needs tuck pointing. It's really deep recessed joints now, and it's ready to be tuck pointed. But once you've mended a leak, like you said, your chimney downstairs, it's going to take a couple of years probably for the masonry to dry out. So that efflorescence is going to keep coming back. You can buy chemicals to get rid of it, but your best bet is to keep an eye on it, just wash it down once or twice a year, soapy water, and just get rid of it. And if it keeps coming back, eventually it will dry out. I've seen walls take 5 years to dry out. They've been this thick, you know, it takes a long time.
Okay, sir?
I have a finished basement, but the main floor, I was gonna get some flooring in, and the guy came in and he had a meter, a moisture meter, and he went around the whole floor and he wanted to replace the whole, all the flooring on the first level. Now, my question is, how common is that in the bungalows, that there's a high moisture content in the wood flooring?
In the first floor
On
level,
the, yeah.
that's not very common.
Well,
So-
did he tell you what the number was? Because you have a finished basement, so it'd be
Yeah.
surprising. Like if you didn't, it's
I can see that,
possible.
yeah.
But if your basement is not, if you're comfortable in your basement and you don't feel excess humidity, then you
Well,
probably.
Yeah.
Probably
So
want
the
to get a
question-
second opinion.
Yeah, is that you need to know what that number is to really be able to figure
Well,
out.
I think he said normal numbers in the 20% range, and I had like 60% here and 40 over here. And
Are your floors, do they look deteriorated? Do they feel spongy?
Are they buckling?
no, it's
Did
just
they get a second opinion?
Yeah. You just want to replace your extra floor.
yeah, well, I do that, but I was
Had
just
to be
wondering
kind, but-
if there was a common problem with bungalows.
At that percent, you would notice if you have excess, and just so you know, if you have excess humidity, your floors you would notice because there's gonna be a lot of movement in those floors, right? They're built very differently than your existing
mean
floors now,
squeaking,
but well, squeaking is mostly because of how they were designed back then versus how they're installed today. You know, today you new construction now, you have plywood and your wood is sitting directly onto that. Right, the old days, you had you had basically the plywood back then, which is like a 1x8. A lot of times you look up, it's like a 1x6 board. But they had furring strips, so your wood was never sitting directly on anything solid. It was gapped. Those gaps in between there is where they're running the electrical, gas lines. There's always things running between those gaps, and that allowed the floor. Kind of was a happy system back then. So because the floors aren't directly on anything solid, that's why there's always more movement in your floors, and that's just the nature of when they built them back then. It's always going to be the case, and there's ways you can go about trying to resolve it, but you can spend a lot of time trying to resolve a squeaky floor. So really the question becomes is, are you having moisture issues? And you would notice it because the floors would open up a lot more. They would be moving more. They literally would be buckled more. At 60% humidity, you would definitely notice. They would not be flat. You know, they'd be shrinking a lot more. You'd see gaps there. You'd see gaps. You'd see movement. So it seems like that's, you know, maybe a secondary reason to why you were replacing your floors in the first place. You know, but.
Well, yeah.
Do you have an insulated attic or like a finished attic with a?
Yeah, it's finished.
It's finished, so you may have ice dams where the water's getting in right at the perimeter of the house. So there you would want to have somebody who's a specialist with insulation, make sure that you're getting the proper ventilating.
Okay.
We have a specialist on the panel here.
If you have furnaces, I see a lot of people like after the installation, or if it is a tighter house, you know, they're running the humidifier nonstop because of the old way or the way they were brought up with humidifiers. So, you know, we were talking about moisture issues too. You know, you can buy a tool at Home Depot that'll tell you the relative humidity of the house, and you want to be in an optimum range. So if you're there, you have to kind of dial that back with the humidifier in a lot of cases, because you want to keep that house. You know, what happens in the wintertime, you know, you're in an uninsulated, leaky house. Winter's the driest part of the year, so you have a dry, so people offset that, you know. But if you have a tighter house, you don't necessarily need to run that humidifier nonstop, and that means shutting the water too at the humidifier. You know, so if you have a humid house, a lot of stuff could be popping just because of that too.
Okay, well, that's probably released moisture.
Sounds like it.
The ventilation, you know, in your eaves and up through your roof system, a lot of times, you know, the roof is insulated just right to the backside of the roof deck.
Yeah.
The plywood of the old space sheeting. And if there's no ventilation coming through there, you're going to accumulate a lot of moisture.
It might not, because our whole roof is attic is our bedroom. So it's really, we got about a foot of space between the outside of the roof and the inside of our bedroom. Or the beams sticking out.
Yeah, and all bungalows are gonna ice dam because they're very leaky, so you have a lot of heat getting to that roof deck, you know, but like he said too, you wanna put like soffit chutes that are gonna go into that slope ceiling and allow airflow if it is like fiberglass material or cellulose or something.
Yeah, I don't know if there is.
Yeah.
The eaves are overhanging, so there's a temperature differential between heated space and then those uninsulated eaves. So basically, if your gutters are you know, if you have a lot of ice in your gutters and you sort of see these ice dams forming at the end of your eaves, that's really common, and so that's an airflow issue that can be resolved. But it can damage your roof, it can damage your gutters, it can get into your walls, so it's pretty important to address it.
I have 2 issues. One, I have like a side room that I'm sure they painted over it because it's white and it's like peeling and it's like, because it's like I've got this like sawdust alongside where, so you can see, you know, the spaces already. So I'm like, okay, what do I do here?
Well, it sounds like it just needs to be repointed. Hopefully it's not too far gone and you have to rebuild it, but that's pretty rare. The paint, that's easy to get off.
Just soap and water?
Well, you say paint or?
I think it's paint. It's white. You know, I don't know. I haven't really looked at it real
Well,
close.
we're lucky now. There's some paint strippers that are green and they actually do work. So it's only the last couple of years that the green paint strippers actually work. So they're worth trying. Any paint stripper that comes in a metal can is nasty. So try ones without metal cans first, and you come out and give you some samples, and you can try them.
I'll talk to you
Yeah.
later. Show you pictures.
Depends what kind of paint it is, oil-based paint or latex. And
Probably both.
yeah, probably.
We've never painted them, but
We do have
the
a,
original owner did a lot of it.
yeah, we do have a paint strip, and I actually did on a Chicago bungalow, on the buttresses out the front they had painted, and it was a 2-hour paint strip. We put it on for 2 hours on a warm day. All the paint strippers work better on a warm day.
Okay.
And it would just oxygen goes through the paint and bubbles up from underneath, and it's really good on limestone. And it's gentle, so same thing. I'll
take your card.
I'll give you some samples.
I have bills that will just eat the heck out of your masonry if you put them on there, so you really have to be careful about that. And also, even the brushes you use, like, just be mindful of how much, you know, like, you know, if you go crazy with, you know, even like a really high pressure water sprayer, sometimes that can even mess it up over time. So just be careful about that. There's a reason, like, you should never ever sandblast anything, you know. There's patience is oftentimes what is most required with stuff like that, and it's naturally going to sort of push off the masonry over time because it doesn't want all of that paint and stuff on it. But sort of the most gentle and patient, you know, thing is usually the best thing for the actual masonry unit.